I would say the things that are important. So if I were you, writing down box number 1, I'd write down the blue highlighted stuff after I wrote down definition. Right? So we're talking about sequences in chapter 13. So the definition of a sequence is a function whose domain is the set of positive integers, and then that little funny looking z is. So usually when we deal with sequences, we deal in subscripts. So I'm going to write down a few terms here to help us around the thing with dot, dot, dot. Okay, the first term is called a sub 1. Second term would be a sub 2, a sub 3, a sub 4. The dot, dot, dot means keep going just like that, and then a sub n. Now when I say domain, I'm talking about these digits down here, the subscript. 1, 2, 3, 4. Those are your positive integers. That's your domain, not the output values. A lot of people get that confused. So as an example, if I gave you a sequence is a function, right? So the input, if I give you 1, 1/2, 1/4, 1/8, and then 1/2 to the n minus 1. Okay, these parts right here, the 1, the 1/2, the 1/4, the 1/8, those are what we call the terms. So what is the fourth term of the sequence? 1/8. Very good. 1/8 is the fourth term. These are all called the terms. These parts down here, the 1, the 2, the 3, the 4, those are the domain values. And then, of course, we finally have the nth term way out on the end there, continuing in that fashion. So if I had 20 terms, I would write the sequence out 20 times, and that would be my sequence of numbers. Okay, we do have a formula for the nth term when we can plug things in, right? As an example, well, the one I just did is a formula. But when we use formulas, we use brackets. So you got to get really good at drawing these brackets here. So a sub n is if I just had, say, 5n. Okay? If a sub n is equal to 5n, how would I figure out what is a sub 7? If a sub n is equal to 5n, what is the seventh term of that sequence?
7 times 5n?
Nope. You're close. You're really, really close. 35. Yeah. That's just 5 times 7, right? That's just 35. So if I was going to write out this sequence, what would the first term be? 5. Good. What's the second term? 10. What's the third term? 15. What's the fourth term? 20. How are you doing this? Yeah, you're multiplying the input value, which is a 1, for the n. Input value for the n, input value for the n, input value for the n, and the outputs are 20, 15, 10, and then 5. So we can go to any term that we want to, or plug in any term that we want. All right. Okay, you guys, let's do an example here. Let's write the first 5 terms of a sub n equals n minus 1 over n. A sub n equals n minus 1 over n. To write the first 5 terms, I suggest that we actually write out 5 little spaces here. So a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. What is the value of the first term? How are we going to get it? We're going to plug in a 1, right? What's 1 minus 1? And 0 divided by who cares is how much? 0. Good. So the first one is 0. Nice job. 2. What's 2 minus 1? What's 1 divided by 2? So now I have a half. What's the third term of my sequence? What? 2/3. Yeah, 2/3. What's the fourth term of my sequence? Okay, by now you should see a pattern emerging. What happens to the numerators? They go up by 1. What happens to the denominators? They're the same as n, right? So this has to be 4/5. Sound pretty good, huh? So basic sequence plug and chug type of stuff, right? All right, so let's bring our calculator up. Mine happens to be silver. Yeah, sweet, right? Okay. And what we're gonna do is we're gonna punch in. Yikes! What did I do? There we go. What we're gonna do is we're gonna punch in the sequence up here that we just did and show you answers. So turn our calculator on. Okay, please hit second. Then hit stat. Then go over to ops, OPS. So move the calculator over to ops. Now we're going to go down to sequent, SEQ, which is number 5. You can either go down to sequent or you can push 5, and it brings you back to the main screen. So notice what you're seeing on the calculator is matching my yellow or this part down here, right? The sequence part. So we're going to punch in the sequence of parentheses, x minus 1, close parentheses, divided by x. Now, they use n's in the book, but our calculator is just programmed for x's. It's just a variable. Okay, then you have to kind of tell the calculator which variable you're focusing on because some sequence have double variables. So we're going to say, okay, calculator, put a comma here. We're going to say focus on x, please. Comma's above the 7, sorry. Then we're going to say comma. Go starting from 1, domain value of 1, comma, to a domain value of 5, comma, please increase by 1s, and then close your bracket. So before you push enter, let me tell you what you just did. Looking on my screen over here, I have the sequence of x minus 1 divided by x. That's whatever your sequence happens to be, right? The x represents the variable you want the calculator to work on. The commas separate everything. The 1 is where you start, the 5 is where you finish, and the 1 in the end is the delta x.
It's like computer science.
Yeah, it's just like computer science. So those of you who've taken it, you've seen it before. Now, when you push enter on your calculator, it gives you an answer. But it's not quite in the right form that we would like. So you can change that into fractions by hitting math, frac, just push enter one time, push it again. Hey, there is the sequence. 0, 1/2, 2/3, 3/4. And if you move your cursor all the way over to the end, you can see 4/5. Pretty soon. Okay, here we go. What we're going to do is we're going to now find the nth term of the sequence here. We're going to find the nth term. So we're going to go in reverse order. I'm going to give you 4 terms. I want you to produce the sequence itself. Start off easy, right? Well, I'll give you this sequence. Sequence is 2, 4, 6, and 8. 2, 4, 6, 8. 2, 4, 6, 8. All right. Here's the key on how to do this, right? You need to find a connection between the domain value and the output value. The connection between the domain input value and the output value. Domain value, domain, output value. What is the relationship between a 1 and a 2, a 2 and a 4, a 3 and a 6, and a 4 and an 8? We're multiplying by 2. So if I replace my domain value with an n, what's the sequence going to be? 2n. That is correct. Now the people who are really, really good at this sections are the people who are really good at seeing patterns. So if that's how your brain works, you're good at picking up the patterns, this will come easy to you. If it's not, you're going to have lots of practice with it. Here's another pattern for you. 1, 3, 5, and 7. Again, the same rules apply. You need to find the connection between the domain value and the output. Domain and output, domain and output. That's your job. What is the connection between this number and that number? Whoa. Thank you. You must be good at patterns. Nth value is 2n minus 1. Everyone should have noticed that 7 is twice 4, take away 1. 5 is 2 times 3 minus 1. 3 is 2 times 2 minus 1. And then 1 is 2 times 1 minus 1. It's the fastball pitch. Try this one. 1. 1/3. Oh, yeah. 1/9. 1/27. Oh. That one's 2 to the n. This one's 2 to the n minus 1. All right. break it down for you. Let's break it down for you. We're trying to find a sub n, right? And what do we notice about the numerator of all of them? It's 1. Why don't you start there? It's 1 over something. What do you notice about the denominators? They are all powers of what? 3. So why don't we just start with that? 3 to the n. Let's start with that. Let's see if that gets us anywhere. How do I know this is not right? Okay, go ahead.
Plug and check, it doesn't work.
That's right. Plug in the first value. Plug in a 1 for n. That would be a third, which is the second term. So I am 1 off. How do I remedy this situation? Yeah. Subtract 1 in the exponent. You got it. Crazy, huh? So the answer would be 1 over 3 to the n minus 1. You'll get better. Yeah, no, that's all that means, right? Yeah. So the factorial symbol means like this, right? N and then factorial, n factorial. What does that actually mean? Anybody know? Yeah. N.
All the numbers before it.
What's right before n?
N minus 1.
Yeah, n minus 1. What's before that? N minus 2. All the way down until you get to 1. No, just 1, right? So as an example, 4 factorial is 4 times 3 times 2 times 1. How much is that? 4 times 3 is 12. Times 2 is 24. Good. Okay, what's 6 factorial? Well, isn't that 6 times 5 times 4 factorial? Ooh. Isn't that just 6 times 5 times 24? Oh. Isn't that just 30 times 24? What would that be? 720. I don't know. Is that right? What do I know?
Well, it's 120 times 3.
Hey. Oh. Is that your phone? So 720? 1,020? What? Oh, there you go. Yeah. Okay, check it out. All right.
Excuse me.
Okay, check it out. Here we go on the calculator. Ready? Punch in 6. Math. Move your cursor to the left to PRB for probability. And then option 4. Aw, snap, 720. There it is. There we go. Okay, here we go. Yeah, what is 8 factorial on the calculator? Go. 8. Math. Over. 4. Enter. Bam.
Oh, what was the 4 button?
Huh? Okay, 9 factorial. 9. Math. Over. 4. Enter. Bam. All right, everybody got it now? All right, cool. Okay, a couple of special cases you need to know about. Everybody, ask your calculator, what is 0 factorial? 1, 0, 5, 108, what is it? 0 factorial by definition is 1. Don't ask why. I'm just kidding. It's just built into the definition. And then what's the other case? Is 1 factorial. What do you think it is?
1.
It's also 1. Very good. Yeah. Whoa. Yikes. No, that's just how I write my explanation points. I'm just happy to write it like that. All right, there you go. So a couple of special cases you need to know about. Okay, let's move on to box 7, recursion formulas. In that movie, there's a famous sequence, right? That sequence is the Fibonacci sequence. Anybody know what the Fibonacci sequence is? You guys remember? Okay, here we go.
Is it 4, 8?
Nope, sure isn't. So here, let's write down the number 1. So Fibonacci discovered this a long time ago. Write down the number 1. Okay. Now, to get to the next number, I'm going to add together the previous 2 terms. So what would my second term be? 1, because 1 plus 0 is still 1. What would the third term be? 2. What would the fourth term be? Okay, I'm going to pause right there. No, it would be 3. Okay. Okay. The last 2 terms. Now, I'm going to pause right there. How do I get the 5th term? What I'm doing is I'm adding together the previous 2 terms together. So what would it be? It would be a 5, right? So that's what recursion is. You can't get this one without knowing something about the ones before it. So what is the 47th term in the Fibonacci sequence? We need the what? We need the 2 before it. You think it's 99? What is the 47th term of the Fibonacci sequence? Well, we'd have to know, if we want to write it out by hand, we'd have to know the 46th and the 45th. But then that means we have to know the 44th and the 40th. And you can see where this argument's going, right? So that's the basic idea of recursion, right? It builds off the previous terms. Not always in this case, but that's the general idea. Here's another example of recursion. Okay. A sub 1 is equal to 1, so the first term they give us is a 1. Thank you very much. I'll take that. It's like the given in a proof. Here's the really important part. The important part to take away is this piece right here. You have to be able to look at that, read it, understand it, and make sense of it in that black cloud. So the question is, when you look at that, what is it saying to you? It's saying to you that the next term is equal to 4 times the previous term. Now, why does it say that? Because, look over here to the left. Okay? If I tell you that this term is a sub n, what is this term? No. Just in general. A sub n plus 1. What is this term? A sub n minus 1. How about this one? A sub n minus 2. So that subscript is just a placeholder. It tells you where to look down the line, right? So if the first term, a sub n, in general, is equal to 4 times the 1 right before it. So what is a sub 2, you guys? 4, correct. What is a sub 3? Very good. You guys got it. 256. All right, that's another example of recursion formulas, right? All right, you guys try this on your own. See if you can 3 and then 5, yeah. So all that was the Fibonacci sequence written out in mathematical terms, right? This is the 3rd term out. This is the first term plus the second term. That's how you get it. Okay, this one here. This one is a little bit tricky. This thing is matching that end right there, right? That's the complicated part. And then you just add 1 and then multiply it by the previous term. So, to get the 2, did anybody write it like this? A sub 1 plus 1 to match the plus 1 part over here. Right? So, this case, the n is a what? It's a 1 in this case, right? Because it's 1 plus 1, rewritten it. So, I take 1 plus 1, get 2, multiply by the previous term, and get a 2. This is the same thing as a sub 2 plus 1. Remember, I'm trying to match that part, right? So the n in this case would be a 2. 2 plus 1, and then times the previous term, which happens to be 2, so the answer would be a 6. Is that how you did it, Olivia? Okay, well, is that how you did it? Yeah, when you see the big giant E, the big giant E is the letter sigma in the Greek alphabet. When you see this letter, I want you to think of one thing and one thing only: add stuff up. Not a fraternity, not a sorority, nothing like that. Just add stuff up, okay? And the way that we add stuff up is very peculiar, right? There are about 1 billion ways that we can add things up together. So you have to have some constraints. Let me tell you what these constraints mean. When you see the giant sigma, it means add stuff up. The bottom part tells you where to start. The top number tells you where to stop. And the a sub k tells you the how part of your sequence. So the sigma means add things together. The k equals 1 says start. N equals your stopping value. And the a sub k tells you how to do it. So here's an example right here. I have a big Greek letter sigma. I'm going to add stuff up. K goes from 1 to 5 of 3 times k. So what does this actually mean? Well, this actually means I'm going to take 3 times 1 and add it to 3 times 2 and add that to 3 times 3. Hey, when do I stop? When I get to 3 times 5. How do you know that? Because it says to stop at 5, right? 3 times 4 plus 3 times 5. Well, how much is all of that? A lot. Well, isn't there a 3 in every single term? So could I factor 3 out? So isn't that just 1 plus 2 plus 3 plus 4 plus 5 all times the 3?
5 with the exclamation point.
No, that's multiplying. So that's 3 times... But wait, isn't this just 5 times 6 divided by 2? Oh, snap. The very first thing we did? Oh, I lost you there, huh? Isn't this... Aren't we just adding up numbers? So isn't that just 15? So this is just 3 times 15, which is 45. So there is a really so that is a really fancy way of saying 45.
So that's like what that second grader was doing in his head.
Yeah, that's what that second grader was doing in his head. That's